Hey, hello there. So today's Leetcoding challenge question is implementation of trie, prefix tree. So yeah, that's pretty much the question. We have to support three operations: insert, which is memorize a word; search is to find do we have the word; thirdly is the starts with. It's do we have a partial match for the searched word. So that's pretty much the three methods the trie data structure should support. Um, and uh, and if you don't know trie, it's basically a n-way tree. So contrast to binary tree, only have two children. In trie, you can have n different arbitrary number of children. So if you look at the string apple, you can see that there are going to be a root node points that has a child with a character with a key value of character a, and that node will have a bunch of child, and one of the child there is going to be the character p, and you would just you imagine there is this tree kind of structure. From the root towards the leaf, it's going to be representing a path that reads like apple. So I just draw this some kind of like a picture. We're gonna have, if we insert apple in here, so it will be a p P, L, and finally E. If we insert another word, which is maybe something like a dog, so it will be have a child to the root with this, which is character D, and it will also be a reference to contain a pointer to the child node O and G. So basically, when we insert a word into this trie data structure, we are populating a root to leaf path if the node are not there. Otherwise, we just traversal through this tree and creating nodes as necessary. There is something that we need to indicate. We need to indicate the end of the word. So for each node here, beyond a reference to the next node there, you actually also have a termination flag to indicate that this is the end of word. So you can imagine we got a bunch of true and false for every node here. That's just indicating do we have a word that ends here. So to search for a word, we basically just traversal through this trie data structure character by character from using the search word. And once we reach the end, we want to check do we have a flag in there. So if we insert apple and dog and search for app, this p here will have a f flag, which is false. So there is no such word in there. If we insert app, we will be traversal through this tree and turn this flag to be true. And if we do the starts with search partial matching, it's also the traversal through the tree. As long as we don't find a dead end somewhere in the middle of the search traversal, then we can return true. Otherwise, it will be false. So that's how we support starts with. So by using this data structure, the insert, search, and starts with, they all the time complexity are all linear with respect to the number of characters in the tree, in the word. So it's basically root to leaf in the worst case. And for space, search and starts with, they don't create anything, so it's going to be constant. But the insert is going to be, in the worst case, every character we have to create a allocate some memories for that. So it's going to be linear with respect to the length of the word. So that's the worst space requirements for insert. And yeah, that's pretty much the quick explanation about what is trie and how it works. So I'm just gonna start and code this up. So the trie structure is holding this whole thing together, but for each individual node in there, it's a smaller data structure. So I'm just gonna have a separate one to make it a little bit cleaner. Fundamentally, this trie node here will hold two things. One is the Boolean flag indicating whether this is an end of a word. The other thing is this parent to child kind of relationship. And and you will be able to access the child by the character. So you're going to be it will be a key value mapping, with the key be the character and the value be the pointer to the actual child node object. And you could use arrays as well, because we are dealing with fixed letters A to Z. But in the case that if you have growing vocabulary, have this to be fixed might not be a good idea. So I'm going to use an unordered hash map for this purpose. So we got two data items here. The first thing is the Boolean flag, and the second thing is the map, which is the character to the node mapping. Let's call it children. Then we're gonna have some public method for accessing this. Okay, first thing first is a constructor, which just set the flag to be false, and the children to be empty. Then we need the setters to turn the flag to be true when we reach the end of the word, and we also need to be able to access the flag's value. So we have a getter and setter for the flag. So this will just be return the flag value. Setter is a void. Which is indicating this is the end of word. Then for the children, we need a setter to create a new character to node mapping, and we also need a membership checking. Do we have a character, a node with associated with this character, so that if it's not there, we can do the insert. If it's in there, we can just traversal through that node. So we need not a getter, but a membership checking. Let's call contains, which takes a character, and it just check whether we have a character in the children. So it's children.count c greater than 0. Lastly is the setter for the children. Which takes a character and the actual node. What it does is to create this association. Jeez. And that's pretty much the trie node class. Fundamentally, it has the flag and the parent to child relationship, where each child is identified by the character. And that's the trie node. And then let's work on the trie data structure. We're gonna have a root node here, which is going to be initialized to be an empty trie node in the beginning. So it's going to be a pointer to a trie node. In the constructor, we basically set this to be a new trie node. For insert, we have to process the word character by character, so we're going to have a for loop. For each character, we're going to check, do we have that? If we have that, we don't create a new node. If we don't have that node character yet, like the first A, if it's a fresh trie, we only have a root. When we see the first character A, we're gonna actually create that trie node and establish the parent to child relationship. So if it's not in there, then we should do this, which is so we can grab a reference to this first. If we don't have the key, then we're gonna use the setChild. Copy please to be the character C and a new node. So that's if we don't have the node. Otherwise, we'll just follow that node and process forward, which is going to be node equal to oh, we need a getter. I'm sorry. We need a getter to traversal inside this tree. So get child. It takes a key, and we should return the child. Does it look right? Yeah, it takes a key and return the children with that key. So yeah. So that's the insertion. Once we are done with this for loop, we should flag the very last node to be true. So it's done by calling the set flag. So that's insertion. Search is pretty much similar. I'm just gonna copy this. The only thing difference is that if we don't have that character, we should return false. Otherwise, we should keep traversal through the trie data structure. And in the end, we should return whether the node, termination node, has a flag. Get flag. And startsWith, it's also very similar to this. So we're working with a prefix rather than a word now. If we just don't have that character, we should return false. Otherwise, we should keep traversal going down into towards the leaves. And if we don't return false in the middle of the search, that means we can successfully process all the character in this prefix. So in the end, we should return true. So that's pretty much the logic. These three parts are really similar. It all starts with this root and just going down the path towards the leaves. In the insertion, it will check if the node is not in there. It will actually create the node and establish the parent to child mapping. Otherwise, it would just in the case of search and startsWith, it just traversals through the tree. The only difference between search and startsWith is for search, you want to grab the flag for the very last character associated with the node of the very last character. But for startsWith, as long as we don't terminate early, we should return true. So that's the only difference between search and startsWith. So let's quickly check. Do I have some stupid mistakes? It looks okay. Yeah, so let me try to run through some examples. No? Arrow? Oh. I should no, not this one. This one. It's a boolean, but I'm not returning this condition checking. So hope that's the only error. Okay, let's submit. Alright, so that's the implementation of Trie. Yeah, that's pretty much the question. Yeah, just very happy that I can code this thing up easily now, compared to 2 years ago. I don't even know this thing existed. Yeah, so that's all.